The next step is to put the two little balls to finish the calibration.
Okay.
So next time it's gonna do. We're gonna open this. You see, it's written enter the calibration standard. So we put them slowly. Here, and then it's easy to close, and then we click on enter, and then we're gonna meet in 28 minutes again.
Okay.
And then we're gonna put the sample.
Alright.
And then after this, it's easy. You just you put your sample and you go 28 minutes and you come and you put another sample.
Okay.
You just have to calibrate once, and then
you can measure 1,000 of samples.
Yes, it's you don't have to do it every time. Just for the first time and do your samples as many as you want. But I don't know, if you want to do it tomorrow, for example, you have the choice. Either you can recalibrate another time, or you just put the samples and check the weight, not the weight. It gives us a number. It gives us it's I don't know, how do we call it in English? Whether it's a number. A number. The number should be inferior to 0.003.
Oh, okay.
Okay.
So this number refers to your samples, or
to the calibration.
Okay.
It gives, when the machine will be finished.
Okay.
It will give us a number.
Alright. You mean after calibration?
Yes.
Right.
I will show you this.
Okay.
It will give us a number. If this number is inferior to 0.003, it's good. Your calibration is good. If it's not, you should recalibrate another time.
Alright.
Okay.
Okay.
Am I clear? Or
Yeah, sure.
Are you sure?
Yeah.
You can ask me if you didn't understand.
No, I understand it.
Okay.
I have some question, but what you said is clear.
Okay.
What I want to know is that you're calibrating. Okay.
Yes.
So what's happened? What's happening?
I don't know.
What I mean when.
I think it calculates the volume of the cylinder.
Alright.
So when you're gonna put your sample and you're gonna have you're gonna have the weight of your sample.
Okay.
It's gonna calculate the volume of your samples.
Alright.
And then I don't know. Finally you have the density. It's on the gram per centimeter cube. So you have your mass.
You have the mass of your sample.
Of your sample, and it calculates your volume. So in the final.
So it means this machine just calculates the volume, and you have.
It calculates the volume of your cylinder.
Okay.
And when you put your sample, it gives you the density. So it gives you the mass per volume.
Alright, yeah. So you don't need to measure your mass because it gives you.
No, you have to measure your mass,
Okay.
and then you enter the
mass.
The mass. You
Okay.
enter the mass,
Okay.
and then it gives you the
density. Yeah.
the density. It's the mass per volume.
Alright.
I will show you.
Okay.
So
we can do it for the next 28 minutes.
Yes.
Yeah.
No, we can meet.
12, 15.
15?
Yeah.
I think so. Okay, 15 or 10.
Okay.
Okay.
So.
Bye.
Yeah, that's it. Bye bye.
Yes, but did you understand?
Yeah, I understand. Yeah.
Okay.
I'm not that much lazy.
Yeah, I know. You just am I?
Yeah.
Am I a good teacher?
Yeah, of course you are. Yeah.
Je vais chanter un peu ce que je exactement dans les syllabes. Mesure du volume à l'instant dans les syllabes. It's on gas.
Okay.
You know we use the helium gas
Mm-hmm.
to measure the density
volume.
or gravity specific.
Okay. All right. And
But this is it. We calibrate to know the volume of the cylinder.
cylinder.
This is it. They said here a sample that we know the mass. We know its mass, but we don't know its volume. So this is the purpose. We calculate the volume, and it gives us the volume per mass per volume. It's the density.
Okay. One more thing.
Yes.
When you put your, for example, 10 gram of your material inside of the cylinder, okay, your material is not compacted, okay, so it has kinds of porosity inside of it, okay. So what's the role of this porosity or this free space around it?
I don't know. Maybe the gas. I don't know.
Penetrate? You mean penetrate inside of your?
Yes, inside the material and the.
So you know what I want to know is that if I just put one particle of my sample, I should get the same result if I put, for example, 10 gram of it. Is that true?
Yes, I guess so.
Okay.
Yes, I guess so. I don't know, but what I can tell you, when I had to do it with my samples, you know, the last time I have the clay. I have clay, bentonite.
Okay.
It's a clay, and you know the bentonite is it's not porous.
Powder?
No.
Pure?
No. And you said what did you say? Porosity?
Yeah, porosity, okay.
It doesn't have porosity, you know, the clay minerals, it's compacted.
Yeah,
you know.
but your sample is not compacted.
No, it's not compacted.
But it has a little bit, but not that
yes,
much.
But not that much.
All right.
But we found a lot of, you know, it gives us the results are not the same. If for example, if I do this sample one time and another time I want to do it again, it doesn't give us the same results. So we thought that maybe because the porosity of the clay or something like that.
Yeah, you know, there is in fact kinds of density. It means what kind of density we are talking about. You know, this is bulk material. When I'm talking about bulk, it means all of it, all of them. When I'm talking about material by itself, for example, I'm talking about this type of this species, which is, for example, black spruce. Okay, so it means what kind of density we are talking about. If we are talking about bulk material, if we are talking about this species, I think there are three kinds of density, and I was not sure what kind of density it measures, you know, because as I said, it comes from black spruce, and black spruce is a species of a wood and trees. Black spruce has a specific density, so I want to know if it's comparable with that one or it's not. I'm not a little bit confident about the information. I mean, what kind of density it gives.
Okay.
You understand me?
Yes.
Yeah, right. So it gives the exact density which related to the particles, or it gives the bulky density which refers to the material.
I think it refers to the material.
Right.
That's because I think that they have with the GS or the gravity specific, we can know what is this. Maybe it's clay or it's.
So why I'm asking, because you said you measured, for example, clay 2 times or 3 times, you didn't get the same answer. So how we can interpret it?
But I think it had just a problem with the machine.
The machine, okay.
Yeah.
If it's
because
right,
after it was okay.
Because if it should be the same. If it wants to change, it means that it's pertinent to the volume or some.
Yeah.
It should be the same. And the same, it could be related to the machine. Yeah. Okay.